In this video, we're going to continue looking at right triangle trigonometry and looking at the part where we're solving triangles. So remember, when you're looking at finding missing information in a triangle, whether it's an angle measure or a side measure, I would recommend doing a sketch of the triangle, filling in the information that you know, then decide which one's going to be your reference angle, either one of the given acute angles or the angle that you're finding, and then label the sides opposite, adjacent, hypotenuse from that reference angle so that you can make the decision about which of your ratios to use. Then you're just going to do the algebra and then remember to check that your calculator is in the appropriate mode. Okay, so looking at an example here, I'm going to identify this angle 39 degrees as my reference angle because it is a given acute angle. Then from there, I'm going to identify that this is the adjacent side, and then this side that I'm trying to find is the hypotenuse. So thinking about my sine, cosine, tangent ratios, I'm going to use cosine because I know cosine is adjacent over hypotenuse. So I'm going to go cosine 39 degrees equals the adjacent side 23 over the hypotenuse, which is z. So now again, we're going to do some algebra here. Multiply both sides by the denominator, which is the variable in this case, and then we're going to divide both sides by the cosine of 39. So z is 23 divided by cosine of 39 degrees. So then you can just go to your calculator and make sure that you're in degree mode. Once you have your calculator, check that you're in degree mode, and then we can just type in 23 divided by the cosine of 39. Let's just round to one decimal place, so we got 29.6. Over here in the second example, again, I'm going to identify the 43 as my reference angle. You could find the missing angle at the top if you want and use that as your reference angle, but just another step where you could possibly make a calculation error. Again, I'm going to label these. X is the opposite side, 14 is the hypotenuse. So thinking about my right triangle trig ratios, this time I'm going to use sine because it's opposite over hypotenuse. So sine of 43 degrees equals my opposite side, which is the variable, over my hypotenuse, which is 14. So here we're going to multiply both sides by the denominator again. So we'll multiply both sides by 14 here. That does isolate my variable. So we just get x equals 14 times the sine of 43, and we get about 9.5. Once you start to look at some word problems involving right triangle trigonometry, you're going to see some of these words, angle of elevation and angle of depression. So what I want you to remember is that these are always created with the horizontal. So as soon as you see a problem and it says angle of elevation or angle of depression in it, think that's a right triangle. Technically, this is an angle of elevation. So an angle of elevation is an acute angle made in a right triangle where the horizontal is on the bottom. And then over here on this other side, this would be an angle of depression. If we think a little bit about geometry here, and I continue each of these triangles and make them into rectangles, recalling some properties that we know about rectangles, this diagonal here would create angles that are congruent because the sides of the rectangle are parallel. Remember, this would be a transversal, this would be alternate interior angles. Same thing over here, my angle of elevation would now be congruent to that angle of depression. So what we can figure out here is that the angle of elevation and the angle of depression are always equal, so it really doesn't matter how you draw your triangle. Whether you draw it as an angle of elevation or angle of depression. The key is to know that those two angles are equal, and it's just important that you're drawing that angle of elevation or angle of depression between the hypotenuse and the horizontal, never the vertical. All right, so here we have a word problem and it has angle of depression in it. So once we see angle of depression, we can think, I know I'm going to have a right angle here. So the angle of depression from the top of the lighthouse, which is 130 feet above the surface of the water, is 6 degrees. So technically, we're at the top of the lighthouse and we're looking down, and this would be my angle of depression, which is 6 degrees. But it makes more sense to me to draw the triangle like this, and I know the angle of elevation and the angle of depression are the same, so I'm just going to put that in there. So the 6 degrees is there, and then 130 feet is my vertical. And then they're asking us to find the distance from the base of the lighthouse to the marker. And so that is the horizontal here, that is x. So just like before, we're going to say, okay, I want to identify the reference angle. So I'm going to use the 6 degrees for my reference angle. And then this is opposite and this is adjacent. So I know that tangent involves opposite and adjacent. So we're going to write tangent of 6 degrees equals the opposite side, which is the 130, over the adjacent side, which is x, which is what we're trying to find. So again, we're going to multiply both sides by x here, and then divide by the tangent of 6. So we're going to get x is 130, and we'll end up with 1,236.9 feet. All right, in my next question, we have this building, which is 100 feet tall. So that's my vertical there. And we're observing a car moving towards the building. So angle of depression. So again, technically we're looking at the angle from the top of the building moving down, but I know that angle of elevation and angle of depression are the same. So if I think about this, I'm really creating a triangle here, and then a second triangle here. So the angle of depression changes from 22 degrees. So this angle is 22 degrees, and then this angle is the 46 degrees. We want to know how far the car travels during that process. So we really are looking for this value right here. At this point, we don't have a direct way to find that value. So what we're going to do is look at the two triangles and find the difference between them. So I'm going to look at the larger triangle, which has 100 here and 22 degrees here. And I'm going to find this value x. And then we're going to look at the smaller triangle, which has 46 degrees here. This is still 100, and we'll call this y. So this is the value of y over here. This is the value of x over here. To get the green highlighted section, we're just going to subtract x and y. So if we use 22 as our reference angle, this is opposite, this is adjacent, so I'm going to use tangent. So we have tangent, again, of 22 degrees equals 100 over x. So again, remember, we're going to multiply both sides by x, and then we're going to divide by the tangent 22, so we're going to get x is 100 over the tangent of 22. Similarly, on this one on the bottom here, we're going to go tangent of 46 equals 100 over y. So here we'll end up with 100 divided by the tangent of 46. Then to find the distance that we were asked to find, we're going to just subtract those two values. And we'll end up with 150.9 feet. All right, so this problem tells us that we have a right triangle with a hypotenuse of 8. So I'm just going to kind of sketch out that picture. Right triangle, hypotenuse is 8, and includes a 37-degree angle. So we know it can't be the right angle. The 37-degree angle can be either of the other two. It does not matter. Just put that 37 degrees in there. Solve the triangle, which means find all missing sides and all missing angles. So I'm just going to label this just so we have a frame of reference. So first I'm going to find angle C, and I'm just going to use the triangle sum theorem there. So using the triangle sum theorem, we know the measure of angle C is 180 minus 37 minus 90, which gives us 53. Then I'm going to call this side over here little a, and I'm going to call this side over here C. So now we can use the right triangle trigonometry to find those. It doesn't matter, again, which one we find first. I'm just going to find A first. So using 37 as my reference angle, this is opposite. And then obviously the 8 was my hypotenuse. So I'm going to use sine. So sine 37 is A over 8. Multiply both sides by 8. Gives us A is 8 times the sine of 37. Then we'll do similarly with C. This is my adjacent side. I'm going to use the 8 again because it was given. So we're going to use cosine. So cosine 37 is C, the adjacent side, over the hypotenuse, which is 8. And then C is going to be 8 cosine 37. So then using your calculator, you get A is 4.8 and C is 6.4.